Ladies and gentlemen, please welcome our next speaker, Viktor Vedmich, presenting the topic, Ideal Blueprint versus Reality for CI/CD Pipelines.
Hello and good morning, everyone. As you heard, my name is Viktor. I'm from AWS, and yes, definitely today we will speak with you about CI/CD. How many of you already know everything about CI/CD? Please raise your hands. So my question, why are you here? Why you decided in 2024 to join to CI/CD talk and speak about CI/CD? So first of all, before I joined AWS, I worked as DevOps engineer more than 10 years, and honestly, I spent a lot of time to do different type of CI/CD projects. I don't know, maybe 20, 25 projects I had to build and create from the scratch sometimes, working with legacy CI/CD process. But anyway, so it sounds like I have some experience. I hope I have some experience. And my goal for today, just like to share my experience with you, maybe to show something new, to systemize the knowledge, what exactly CI/CD, why it's so important, what's exactly the difference between CI, continuous delivery, continuous deployment, what kind of best practices do we have? And what's most interesting part from my perspective, how we can measure our CI/CD process. Because, if you don't measure, most probably you don't control. If you don't understand what's going on with your continuous integration, with continuous delivery process, most probably you don't control this process. Someone did this amazing job, but you don't what's exactly happening under the hood, why we have so long build process or deployment process. And I will share with you my ideal blueprint pipelines, how it should be looks like. Again, it's from my experience perspective. I'm not going today to speak with you on implementation because some of the people prefer to do it based on the Jenkins. Some of you most like to do through the GitHub Actions. Maybe you still working with cruise control. Who knows what is cruise control? Please, right? Oh, you know what is cruise control? Four people. You see how I old, yeah, so that sounds like you also not very young people. So this was my first continuous integration tool, Cruise Control. I recently figured out that ThoughtWork company made it, from ThoughtWork was released Cruise Control. It was wonderful product. So anyway, we will start from a review life cycle in general, what's exactly continuous integrations, how it's related, like what's the first step, the second one. And for sure, when we start to create our project, we start from the source. Yeah, it's very important part because it's the source where we store our code. And the next steps, like it's a build, test, production. Sounds super easy, but why still so popular DevOps area when we have to make a lot of automations, continuous integration, delivery? It's very important part. I still remember this time when people spoke about, hey, we have 5 deployments per day. It's like amazing job. And nowadays, like people have 100,000 deployment, especially if we look at the AWS. I know in AWS, we deploy like 100 times per day, different service teams, but still like it's amazing numbers. But everything started from source. It's so important because sometimes people to forget that continuous integration started from source code. Because if we speak what exactly continuous integrations means, in these two words we have continuous and integrations. Everyone understands continuous. It should be happened every time when we do some part of the job. But what exactly integrations? Some people said, hey, integrations means like when I made the build, run my unit test and see the result. In reality, it's not true because continuous integration started when you made the selection of branching strategy. So I hope all of you use currently Git. It's a main source, like where you push your changes, not SVN anymore. I hope so. So, but I met recently people still working with SVN. I understand, but like my preference is Git. So why I want to spend a little bit of time on branching strategy? Because like it's ridiculous when like it's so dramatically important in the future, because based on your branching strategy you will implement your deployment strategies, how you will deliver it to production, and what kind of currently options do we have. The first one, it's not option. Please don't use Git flow if you don't have some specific reason for that. Why? Because first of all, Git flow was designed and implemented by Vincent Recent in 2010. It's like 14 years ago. And the main goal of Git flow was to develop a product which can be delivered through the like compact disk. For example, we're working on some game or office or I know something what we distributed through the compact disk and deliver it to our end users, not through the web applications, but somehow to install and working with this application. My experience with Git flow, I joined one of the project and opened the list of the branches and started to scrolling. I'm scrolling one screen, second screen, third screen. So I stop on the one like I achieved 10 screens and it was only branches. I started to speak with developers and ask, hey, people, what's going on? Why do we need so many branches? Like we create this branch because we wanted to make refactoring. This branch is 3 years old. Okay, and what about this branch? Was the second iteration of refactoring. We decided to refactor our front end. This is 2 years old branch. Have you merged these changes to the like main branch? No, we just like started to work on that and forgot about them. So Git flow a little bit difficult. I mean, like from implementations, but I know there sometimes of the reason when you need to have some strict definitions what will be released on your production, how you exactly release, how you test. Sometimes Git flow will be best options, but most probably in 80 or 90% in my experience, I would say no, please don't use Git flow. It's a little bit overcomplicated, especially if you work in when you develop application which is distributed like web, like you deploy to cloud or to Kubernetes or to someone like super quickly and every day. What other options do we have? Most commonly currently used in development areas, it's GitHub Flow. What's the difference? So first of all, we have a main branch. It's our main line where we try to support it as a stable branch, and we can deploy at any time to production through the main branch. So one of the most important part from Git hub flow that it's said like we need to have only short-lived branches. And another option is like code review. Before like my preparation, I did some couple of the researches, what's the current state of continuous integration delivery in the world. And ThoughtWorks, again, like it's a huge company, they release every 6 months technology radar. It's a opinionated view what's going on with IT in general. And Martin Fowler, working for ThoughtWorks radar. Today, I said like a lot of times with work, not AWS. So as you can see, not any implementations on AWS. So he updated recently his huge article about continuous integration delivery. Highly recommend to review if you want to go deeper, like on 400 level. So what's the problem with code review? Code review initially was created for open source when you have different developers who distributed across worldwide and you don't trust them. So it means like it's an environment when I am like, for example, as a senior, I am done with my job and I don't trust a person from other country, which is based, for example, in the United States. I don't know what's your level, for example, of the knowledge in development process and so on. But how it's affected to our process in our life. So sometimes we implemented code review for so long time and we stuck with code review. Please trust your teammates, please trust in your environment and make code review faster and quicker. Why important? Because sometimes we create a GitHub flow and we don't have at all continuous integration because we just stuck on review of our code. So we be very careful with code review. It's very important part to grow as engineer, to learn from each other, for example, from senior to the junior. But at the same time, if we create a lot of code review, we can like waiting for a long time to move on the next step. What else? Branching strategies can be also trunk-based development, super popular in startups. If you need very quick development process, so what's the main difference? So first of all, we have not like a main trunk, and the trunk branch we merge or update trunk branch every day. It means, like, for example, we have two different developers, like for example Anna and Viktor, for example, and when we do any changes, as soon as we not done with a feature, as soon as we done with some part of our job, we try to merge these changes to trunk. It means like trunk we try to save as stable as possible, but at the same time we don't guarantee that trunk can be deployed to the production. We try to do as our our best. So we try to commit to trunk to every day. So it means like at least every day. The biggest challenge with trunk-based development, how I can commit my changes if I'm not done with my new feature. And the answer will be feature toggle. It's here. So what exactly feature toggle? Sometimes people call it feature flags. You create some configuration of your application and create like a flag. Please not enable this functionality. I am not done with this functionality. As soon as you're done, you just enable this through the feature flag, and it means like you can enable this feature exactly on the production. That's exactly how, for example, AWS deploy most of our new features to production system. We deploy it like very often, like every day, but we not enable all of the functionality. We enabled exactly when we made all of the tests, blah blah blah, and ready to run for our end user, for our customers. Also, super quickly, interesting part of Git. I know most of you knows what is Git, but maybe you have never heard about what is Chirpik. If you're not, so what exactly is? You have a trunk, and if you need to merge one, for example, commit, you have some bugs, for example, on production, you figure out about that, make the changes in the trunk, and you can cherry pick or merge only exactly these changes to your release branch, like release 1.1. So this is exactly when we start with continuous integrations. Again, continuous integrations, it's when we merge our changes to our source code, to our Git or SVN. It means like we integrate our job, like you, me, work together in one application, in one microservice, for example, and we merge our changes, we integrate our changes. That's exactly where continuous integration started. We are going to build this blueprint. You see some, like boxes, so we will fill it like a little bit later. So what's next do we have? So for sure, like the next one, it will be test. So we need to run some tests, and that's where most of the people started to think like it's continuous integration. Why? Because, so first of all, what's the main goal of continuous integration? We have to automate everything as much as possible. So as soon as developer finish with job, like I'm done with my functionality, I commit it, push, and automatically starts the process of build. The main goal of two main goals, I would say, from continuous integration. The first one, it's most important one, it's feedback loop. This is the main reason why continuous integration was created in general, why we had Jenkins, GitHub Actions, Code Catalyst from AWS, Code Build from AWS again, TeamCity, for example, or many other tools, what you prefer. So to have a feedback loop. Feedback, it means you, again, like you done with your job and run in one central place, test, code review, and everything else. And this is exactly what feedback is. You run and figure out that you don't fit to unit test, or for example, some static code analysis said for you, hey, you have an issue, you store some secret data like password in Git. So be very careful. And this is feedback back to you as a developer or to you as DevOps engineer and said, hey, you have to fix it. The second one is artifacts. So we prepare our artifact and store in some artifactory. How it looks like from diagram perspective. So first of all, what we add from the previous slide, we have CI/CD dashboard. This again, it can be your Jenkins, some central place where you see what's going on with currently with CI. what's the build queue, what's the result of unit test, and so on. And what the step we should to add to our continuous integration. Code analysis, again, it's static code analysis mostly. It can be just linters, for example, or maybe more advanced tools like SonarQube or something from AWS or something from third party, like up to you, what you prefer. Run build, like for example, prepare, like run and build on Java, .NET, Go, like depending what language do you use, for sure. Like if you run in the Python, most probably you don't need to run as a build, but maybe you need to like to download some dependencies. And unit test. Again, unit test, just like to be aligned. I understand most probably you understand it, but I want to say it out loud and make sure that we are on the same page. What's the difference between unit test and integration test? Unit test never will go outside of the system. It means like we in unit test, we never test that we store something in our database or file system or in some third-party services. Unit test is just to test core functionality. So for example, I have a functions which just calculated two numbers or proceed collections of the data. So I have input 2 and 2, and I need to have a sum of these functions. So the result of the unit test, like to make sure that 2 and 2, it's like 4, not 5, not 6. So it's what's unit test. Again, unit tests don't store anything on your file system, on database, on your cache, on some other places. Unit tests only inside in your application, not going outside. And you also see here, like I have quality gates. In every step, I have this quality gate. It means like if I failed, for example, with static code analysis or with my unit test, I stop this process of continuous integration. And this is exactly I got my feedback from my system, from my continuous integration to developer and say, hey, John, can you please fix it? My continuous integration. So like, John, you have a problem with this functionality. Can you please look at this because you not fit to like pass all unit tests, for example. And the output of continuous integration for sure will be our artifacts, artifact repository. We store our artifacts, which we have to deploy to all other environments. Again, please don't create artifacts for every environment. If you need some configurations for productions, make it as configuration path, not to create a separate build for production environment, for staging environment. You create one time your artifact and deploy this artifact on the next environment. And also don't forget that you need to make some version of your application. I know that's most probably you say, I know what is semantic versions. Super quickly to explain if you're not familiar. So in semantic versions, we have 3 numbers. Major version, it's like when we have dramatically changes, like for example Python 2 and Python 3, so we cannot use code which is written on Python 2 and Python 3 versions, like you understand what's the logic. Minor changes, like when you add some new functionality, patch, it's like your build. My experience show me that it's very good practice to put in patch version also hash of your git commit. Why? Because in this situation, you will very quickly to understand what's the current version from code perspective on your staging environment, on your production environment, on your any environment, because you will have this traceability, which is matched to your Git repository. Not only some magical numbers, 1.2.5, what exactly is, what the state of the code is of this version. So if you add a hash commit of your in your patch version, you will be able to trace very, very quickly. So we're moving on. So we currently covered like source, build, and test. And the next one, as you can see, it's continuous delivery. So what's the main goal of continuous delivery? First of all, it's continuously after we're done with continuous integration. So we're done with our artifact. So we prepare this artifact and we deploy these changes. Like we start to deployment activities. We promote our artifact to some environment. So it means like we run this on some environment. Let me show you from diagram perspective. So first of all, super important part. Again, it's like based my lesson learned from 10 years of experience. infrastructure provisioning also should be part of your continuous delivery. What I mean, like if you work, for example, in your on-premise application, it can be your Ansible script, it can be your Puppet script if you use still Puppet, or I don't know, Chef, for example. If you work in cloud, most probably it will be Terraform or CloudFormations, or maybe Pulumi, or maybe something else. Doesn't matter. Currently doesn't matter, but your infrastructure provision and configuration, how you create this environment, you also have to should be a part of your continuous delivery. So you create this code also as a part of the whole development process, and create first environment. Like in my case, it's dev environment. It's my first integration environment, and where we run additional a couple of the tests. So in my case, it's integration test and acceptance test. And again, as you can see, I have quality gate, which is returned to my continuous integration dashboard, to my, for example, Jenkins, to share with me what's the current status of integrations test. Currently, when we work with integration, this means like we integrate with external world, like for example, with database, with other microservices, and so on. So for sure, in continuous delivery, most probably you will have another environment, and this is why I said you need to create artifact and store your artifact in artifact repository, and after that promote it to other environments. For example, to dev environment. In my case, the next one will be QA, or it can be in your case, I don't know, staging, UAT, user acceptance test, or pre-prod. Doesn't matter how to call it, but it's like next step of your environment. And on every different environment, you can run new scope of the test or type of the test. So in my case, as you can see, I have on UAT or pre-productions, I'm going to run performance test. So performance test, it means like we check the performance functionality. So in my experience, again, how we did it, like we have absolutely exactly the same amount of resources on our staging or pre-prod environment, run through the Gmeter performance test, and look at the analysis with previous tests, previous releases, for example, and compare it. For sure, it can be different type of the test. Like, I don't want to say that you have to run all of them. Maybe one of them mandatory tests. For sure, it will be unit test. You have to write unit test. I don't want to say that you need to cover 100% of all of your code, but at least, I don't know, like maybe start from 30% or 20%. It will be good start, but try to achieve like magical numbers like 80 or 70%. But it's not like main KPI. So again, different type of tests depending what's the how much of how many resources do you have, and so on. So we move on to the next step. It will be continuous deployment. And what's the difference between continuous deployment and continuous delivery? The main difference, it will be automatically deploy. So it means like we don't need to wait for some approve. We don't need that someone will say, hey, I'm happy with this release. Can it move to the production? But there is a challenge. How I can deploy anything to the production without affecting my customers, my end users. And I prepare what the current deployment strategy exists, not like on the market, but in general, what kind of deployment strategies exist, and what their, like parameters, what their functionality or something like that. So first of all, one of the most important part will be zero downtime. So it means like we try to avoid effect on our end users, and we have 5 different type of deployments. I will go deeper for everyone, like super quickly, but as you can see here, I create these characteristics like zero downtime, real traffic testing, target users, cloud cost, rollback duration, impact user, and complexity of setup. So first of the strategy, it will be recreate. Most probably you see that financial service like banks still working on recreate strategy. What this means, like you get some SMS, for example, on your mobile phone, and your bank said like, during this tonight, we are not going to accept process through the ATM. So you will not be able to get your cash, for example, or we will have some issue with transactions or something like that. So maintenance, it means like we just stop previous environment or delete previous environment. It will be best options, because in this situation we apply immutability of our infrastructure and create from the scratch the new environment. But my experience showed me that most probably you just stop the environment, apply new changes, deliver these changes. Maybe you will see some configuration drifts, but again, like best options will be create from the scratch. If you have your configuration management or infrastructure provisioning part of continuous delivery, you can create, recreate. But if you don't have, you have to do it like manually, just like stop and apply a new version. Rolling update or rolling sometimes. So in these situations, what's going on? We have some small part of new version, and we transfer, like start one instance of new version, and if everything looks good from automation perspective, this instance up and running, we start to send the traffic to this new version and down on our old versions, and continuously rolling, like add new resources to the new versions. Controls through the load balancer, like super quickly we can move from old version to new version. Not super quickly, because we have to do it like step by step. We can create very quickly from the scratch new version, but we move pretty easy. Out of the box available in Kubernetes world, in many cloud providers. If you have some managed services and you need to make some updates, rolling update most probably will be available out of the box, because it's super easy to implement. The next one, blue-green. So like two environments. One of them drawbacks of the blue-green that you need to support two environments. Okay, support, it sounds not so incredible, but you have to pay for two environments. These two environments should be absolutely the same. So if you have in your production like 100 virtual machines, so it means like in your blue and green environment, you will also need to have these 100 virtual machines, and you have to pay for all of them. So control through the load balancer, one of the main benefits from blue-green. So first of all, you can test real production, like real code. So in rolling update, you're not able to test it. In blue-green, you can do it. And what interesting part is that you can super quickly switch from version old to version new, or for example, if you need to make some rollback, just through the load balancer, you can do it. Canary deployment. Interesting picture, yeah. So I tried to decide to go deeper and understand why canary. Why canary? It's a bird. Everyone knows like it's canary. It's a bird, super small birds, and I figure out that in Spain, miners who works under the like in the places where the quality of the air sometimes can be not so good, not like Bitcoin miners. I mean like real miners. Yeah, so how they test the quality of the air? So they use this small bird and put it to the place where they're working. And if this bird is alive, like super small part, like super small bird, and if this animal like is alive, it means like everything looks good from air quality perspective, and the miners can come in. So it's very transfer to what we have on real production. So what is canary deployment? We move to real new version of environment like 5%, 10%, depending on what you prefer. In my diagram, you see 10%, and I send real traffic to a new environment and see what's going on, like based on my observability, logs, trace, metrics, understand everything looks good, my customer's happy, we don't have some performance issues or something like that, and we can move all other traffic to new version. The next one, the most interesting and more complex version of deployment strategy, it's A/B testing. So first of all, A/B testing most probably we will need only when we need to have some business changes, like for business metrics, where we control business metrics. Let me explain what exactly is A/B testing. So first of all, in A/B testing, we select a target of group of real users. So for example, you have some game applications, like create a game, mobile game, yeah, and you want to select of people who spend in your application every day 30 minutes or 1 hour, and you're going to do some redesign or implement new quest or to do something new, and you want to test how long people will stay with new functionality if you release only for this group of amount of people, because you don't want to deploy it for everyone. You want just like to test on some small amount of group of people with specific characteristics, like in my case, who spend 30 minutes every day in my game, and I want to test this functionality. So I selected this group and send the traffic to my new version of the applications. So as I know, on the market currently does not exist very good solutions to make A/B testing. So most probably you will need to do it manually. I mean, like to create your custom solutions or integrate with some third-party solutions to select these target groups. Let's back to our table. So characteristics of deployments. So what's we reviewed? So first of all, recreate downtime. Please don't use recreate. It's like you will affect your users. Rolling, so good options because zero downtime, super like it's super cheap because like you create for very short period of time new resources. Rolling, if you need to do rollback, it will take the same amount of time when you may deploy new versions. You will most probably not impact of your users a little bit, and complexity super easy. Blue green, what's the main options is like? So first of all, rollback will be super quickly, and maybe you will affect your users because when you make this network switching to the new version, if you have some sessions on previous environment, maybe you will affect like previous your current users. So. Canary, I show it can be a little bit complicated to implement, and A/B testing. So first of all, real traffic, target users, and one of the most complicated versions of deployments what you can do in your production. Okay, we moving on to the next part, metrics. As I said on the start, if you don't measure some system, if you don't measure your like performance of your continuous integration, most probably you don't control your continuous integration, continuous delivery. On the market exists very popular metrics, which is called DORA, or it was created by a company, not like company, by research. DevOps Research and Assessments is currently a part of Google. So what the metrics is? The first one, deployment frequency. So how often do you deploy new functionality to the production? Not like to the dev environment or QA environment, to production. The second one, it's lead time. So it's not lead time, like, so my understanding of lead time, that's when I have an idea to implement something, and lead time is means like from idea to production. No, lead time here, it means like how much time will need it as soon as I committed all of the functionality to, for example, to the main branch in Git, and all of this procedure of running continuous integration, my tests, or for example, code review. Again, remember code review. You remember, like you can stack on code review, all of this stuff. And when I will see these changes on production. The next one, change failure rate. So how often do you have an issue when you deploy to production? Like I see the correlation. If you have more frequent deployment to production, most probably you will have less failure rate. And time to restore. So again, like how much time you will need to make this restore to a normal situation for your production. And what these people said, like if you have deployment frequency like on demand, it means like you can deploy at any time, or for example, as soon as you're done with all of your development process, you can deploy to the production. Your lead time less than an hour, so it means like this time when you commit it to the main branch, so it will take only less than 1 hour to deploy it to production. And failure rate very close to the zero. You like elite software development teams. In the latest researches from 2022 and 2023, they didn't report it about these metrics. In 2023, they mostly spent more time on generative AI and how it's affected on DevOps area. So, but still, I believe this metric is very important. But it's not is that what I wanted to share with you. So my personal metrics, what I created when I work with very difficult customers, I would say. As customer didn't trust to us as a company because it's like very huge Germany customer, and like when the customer said like, okay, you are sounds like a good company, but like we don't believe that you can do some good CI/CD. Okay, let's try to measure what we currently have and what we do with our continuous integration, and do we have some improvements or not. So the first metrics, what we had, it was build failed percentage. So again, like you committed something, you make some changes, and how often it will be red. Like we prefer to see the green light on our continuous integration. So it's like what the percentage will be red. My recommended values will be around 5-10%, not the more, because in other situation, most probably developers and other teammates will not trust your continuous integration system, because if you have like every second build is red, is failed. So what's the reason to look at the continuous integration dashboard? Time to feedback. It's very, very, very important, guys. So like, I hope you will learn something from my session today. At least remember time to feedback. Less than 15 or 30 minutes. I put it here as a number 30 minutes, but my recommendation will be 15 minutes. Why? Because we are human. We are not generative AI robot who can control everything and so on. We are human, and what this means like a human. So I'm developer, for example, or I work as a DevOps engineer and am done with my Terraform code. I done everything, I committed and push it to my main branch. So, and waiting for like, I don't know, going to drink something like coffee or speak with my colleagues. And during these 15 minutes, I can remember all of this context, what I did in my task, what I did in my ticket. After 15 minutes or 30 minutes, most probably I will take another task. So it means like I will switch my context in my mind to new code, to new functionality. And it means like I will need, if I need to back to my previous ticket, I have to spend again this time to look at this code, remember what I did here and so on. So try to make sure that you have time to feedback less than 30 minutes. It's a time window when people most probably switch to the next task, to the next some, like responsibilities or so on, so on. Percentage of unknown to known. So it means like you don't have any issues on your infrastructure, in your continuous integration infrastructure. I mean, like you have Jenkins, and sometimes Jenkins can be not very stable. Jenkins is amazing tool as continuous integration, but if you have a lot of plugins, sometimes it can be terrible to support it. So like this metrics show me how often I have an issue with infrastructure. Queue on your build server, maximum queue build servers less than 5. So if you have like long queue and I know like 20, 50 builds is currently in the queue, it means like developers waiting for when their their code will be tested, run through the my continuous integration, and it has huge correlation with time to feedback. So bigger queue on your build server, bigger time to feedback. Average queue time, so again, like less than 10 minutes, so it means like very, very quickly can be proceed. And the last metric, previously I call it like pull request count, so how many pull requests do you have? It means like to show that your continuous integration proceed during the day. I don't like 100 pull requests, you run 100 continuous integrations builds and so on. Currently, I would say I would add one more. It will be called like pull request cost, with the same abbreviation like PRC, but with a little bit another definitions, pull request cost. So in nowadays, when like economy situations, it's a little bit, I would say, difficult, and we need to control how we spend in clouds, because clouds, it's amazing place for scaling, but at the same time, you can have, I know, dramatic bill at bill at the end of the month, or for example, at the end of the year. So please control how you spend your money in the cloud. So what will be our blueprint to summarize everything in one place? Again, very quickly, we start from our code. I want to remind you again that continuous integration started from your version control. You go through some process. So again, it can be dependent on your configurations. It's, like to show you a possible way to inspire you, for example, or show you where you can have some maybe opportunity to implement in your configuration, in your continuous integration. So in continuous integration, we run like code analysis, like up to you what the tools to use, unit tests run, artifacts. Please remember that the main goal of continuous integration, it's artifact and feedback to developer, to DevOps person, like to show like, hey, you have an issue, for example. We provision our infrastructure. It also should be part of continuous delivery. Run some amount of other tests, like performance, synthetics, integration, acceptance test, and continuous delivery. Most probably you will need someone who said like, let's go to the production. I approve these changes, or you have like release lifecycle every 2 weeks. Like for example, in my experience, mostly we deploy on Wednesday because it's not a Friday. Please don't deploy to production a Friday evening. So today you will have after party. So today after 5 p.m. please don't deploy to production. And you see, I didn't mention anything about these blue blocks. But I want to spend like my last 2 minutes to set about that. Continuous preparations or monitoring, it also should be part of your continuous delivery, continuous integration. Why? Because you have to control not only your production from monitoring perspective, from observability perspective, but also low environment. Why? Because for example, on QA environment, you, for example, can work together with QA teams or with other microservice teams. And if your QA environment is broken, it means like other team cannot use your environment. Please control, monitor your lower environment and create the instructions for what you should do if, for example, database does not respond on your query. If you have these instructions on low environment, most probably you will have the same instructions how to fix it on production. That's it. Thank you very much for your attention, and it was CI/CD.
Yes, thank you for really amazing speech, but we have a lot of questions here, and
A lot of, okay.
Yes, somehow you are popular this morning. Okay, I don't know. Do you see them? I think that we can go and read them. Is it possible to present it on my screen?
What's the policy for removing feature flags? I see interesting questions. Maybe so. First of all, maybe we have some questions here inside in the room. Yeah, like I see we have. Like, let's start one question from room and one question from online. Yeah, let's do it this way if you do not mind. One question here.
What is the proper way to measure DORA or those other metrics in distributed systems? Because like different services could have different build time, and even code reviews could have different requirements for core services or minor services and so on. So how do you make an average or something like that from all those metrics?
First of all, want to pay attention that DORA as a metric exists more than 3, 4, 5 years, something like that. And interesting fact that I don't see good implementation on any continuous integration like GitLab CI, GitHub Actions, TeamCity, Azure DevOps. None of these from AWS, Code Catalyst, none of these tools don't want to implement DORA as a metrics at all. So recently, again, it will be reference to ThoughtWork Radar. Can you please look at the ThoughtWork? I saw one of the paid version of the tool. I don't want to advertise anything, but I saw one of the paid tool can currently do DORA metrics to collect what your deployment frequency, what your failure rate connected to your Bamboo, GitHub, and other tools and your monitoring system to collect everything in one place. This is how you can do it, but it's paid version. I don't remember what the tool, and I don't want to advertise here on the conference. You can look and find by yourself. Swordwork Radar, like it's like also a little bit as an advertisement, but anyway, so it's like where you can find your answer. Currently, honestly, I don't have like to say it. You should do it this way. So, question from.
Yes, let's go to the questions because we
we
don't
can
have too much time. What about end-to-end tests would we be getting a merge?
End-to-end test can be run, and most probably it's a continuous in deployment process, like delivery process. So you can run your end-to-end tests there on these environments, like QA, for example, UAT, and so on. Should we run this test before we merge to the main branch? It's a good question. So if you can implement it and do it, like in the way that for every branch you create a separate environment, it will be great to have end-to-end test before you merge to the main branch. But if you don't have these capabilities, based on the cost, based on your tool set and functionality, I would say you can run your end-to-end test on this like QA, pre-production, UAT environment. Yes.
Okay, actually we are running out of time, and when
sorry.
new presenter is coming, I really believe that we have a lot of questions. So you see it, I think Viktor will not disappear from this conference soon, so
not.
You can catch him in the room. Yes. Okay, so first of all, I would like to thank you and to give you a small present.
Thank you very much.
Yes.
Thank you.
Thank you.
Thank you.
And warm applause to Mr. Viktor.
I hope you learned something new today. It was my main goal. Thank you very much.